Hello and welcome to this podcast for Electropages. I'm your host, Robin Mitchell, and in today's episode we are joined by Flip Electronics, and our guest is Gary Beckstead, the VP for Quality and Warehouse Operations. So, first thing I'd like to say is thank you for joining us today, and in just a few short words, could you tell us what it is that you do and the things that you like to do in your free time?
Good morning, Robin. Thank you for having me. I am responsible here at Flip Electronics for all of the inbound, outbound logistics, as well as all the compliance issues. That covers counterfeit mitigation, control plans, ISO compliance programs, as well as being the subject matter expert for any technical issues. In my personal life, I'm into woodworking, and I'm a massive geek, specifically Lord of the Rings and any of the original trilogy of Star Wars.
Lord of the Rings. Fantastic. Lord of the Rings. Yeah. Absolutely brilliant series. I'll have to admit, I'm not too keen on the new series. For me, the first three were always the best, and I think they should have just left it at that. Of course. Yeah, go on.
I grew up on Tolkien, the original cartoons set the bar for me. I don't know if you had those.
Yeah, they were the 80s. Were they the 80s or 70s, those cartoons? I think they were the 80s, weren't they? 70s. Oh, okay.
Yeah, I'm dating myself now.
Yeah. The age is getting higher. Anyway, let's get down to business then. So I suppose my first question is, what is it that we're going to be looking at today in this podcast?
I really want to explore a topic that doesn't get covered very much, and that's more about the real specific realities of the consequences of counterfeit electronics. There's a lot of conversation about how we detect counterfeits and the financial consequences of counterfeit electronics, but there isn't a lot of conversation about the real world consequences and how they impact the lives of ordinary people.
So let's start with the first question. How big is counterfeits, or how big of a problem are counterfeits in the semiconductor industry in general?
That's a great question. And in the past, when I've tried to address the answer to this, I've had to point out that there's a couple of different ways to measure that metric. More commonly, you see it measured in dollars, and I think that's the easiest way to measure it. Typically, you see conservative measurements in the single-digit billions per year, which is a very large number until you put it against the metric of the trillions of dollars that the electronics industry as a whole is. You can also see it sometimes measured in the number of units, which becomes more of a shock value when it starts looking at tens of billions of units per year. That becomes less significant when you consider that you can have a single reel of, say, 0805 size capacitors, and there's 10,000 pieces on a reel. Now you have 10,000 units of counterfeit parts. But to me, I think that the undervalued measurement is the number of lives that are impacted by counterfeit electronics, and especially the number of hours that are wasted in productivity and that are lost in design efforts. When you start looking at the lost time on a production line or in the returns and repairs because of failed consequences.
So if we just go back to a second on a figure that you mentioned, you said billions of dollars. Let's just be clear. Is that just the financial impact of companies who have lost out because their parts were faked?
That covers also repair costs. So if you have, let's say you have a $100 microprocessor, and it turns out that the parts that you've just mounted on your board turned out to be counterfeit. Maybe they were refurbs and you thought they were new and they fail in the field. So you're not just replacing a $100 part. Now you also have the rework of removing the counterfeit from the board, refurbing the board itself, and then buying the new parts and placing the new parts. And what was a $100 part that maybe you saved $20 on the original production run because you bought it from a gray market broker, now you're spending $300 or $400 per part between the rework and the actual overhead.
And so you've not just lost the money in the part itself, but then also the work afterwards as well. Does that figure also include? I suppose you describe it as kind of like the consequences of those parts being counterfeit, such that if someone got hurt or something got damaged and you were liable for that damage. Does it also include that figure as well?
Unfortunately, no. Frequently, what we're seeing is that the accountability for counterfeits doesn't typically go beyond just the manufacturing cost.
Right.
One example that I saw was that if, for instance, a house burns down,
Yeah.
the news is reported that the house burnt down. What's not reported is that the source of the fire was the counterfeit RAM on the board inside
Exactly.
of the smart thermostat that shorted, and that's what led to the house fire.
And so that figure doesn't, as you would probably say, doesn't show like the true nature of the size and the scale of the damage caused by those counterfeit parts.
Exactly, exactly.
Now, when it comes to counterfeit parts, as you say, everyone talks about how to spot them or how to identify them, how to get them out of your system. But as you say yourself, no one ever really talks about the consequences of those parts. So I think let's start with the first question in that sort of line of thinking. What's the worst case you've seen where counterfeit parts have caused a major disaster or a serious impact to human life?
Um, I think the one that comes to mind first was the tragic loss in 2020 of Lieutenant Schmitz of the United States Air Force. His was a story where he was an Air Force pilot who was bringing in his troubled aircraft, and on landing, fired off his ejection seat. And due to what was later determined to be suspect counterfeit components in the controller unit, the parachute for his ejection seat did not deploy.
Oh my
And
goodness.
Lieutenant Schmidt's life was lost as a result. Subsequent investigations by the Air Force determined that not only was the seat not adequately maintained, and in fact, it hadn't been repaired in over 3 years due to supply chain issues, but they actually discovered several electronic components in the seat and in the control unit itself that had what are considered stereotypical signs of counterfeits, including abrasion marks on the top and signs of previous use. And of course, in that case, we have the ultimate cost, which is the loss of a life. But you have, furthermore, the consequence of how deep does that go? How many other states are there? And how many other potential aircraft incidents have happened that are unknown to us that are the result of that supplier or suppliers who provided those counterfeit parts to the Air Force and other DoD outlets.
Now, being completely honest, I've never actually heard of a case as like a real case where someone's actually died as a result of counterfeit parts. So that's honestly shocking to hear that. Not only did it happen, but then they found out what the cause was, and they were able to say that it was counterfeit. And it does make you wonder, how do you think that could have happened in the first place, especially if we're talking Air Force equipment?
It's particularly shocking in light of the fact that it happened in 2020. I mean, we're talking a full 8 years after the Senate Armed Services Committee had their full meeting and released their findings to determine that there was such a problem of counterfeits in the DoD supply chain. How is this continuing to happen? And in the end, I can only imagine that it's a result of business as usual, that while on the surface we are all still clamoring for stronger controls on the supply chain for counterfeit mitigation, at the end of the day, we're still dealing with just get me the parts now. And we're not really evaluating what is the real cost to these decisions that we're making. And at the end, the real cost is the loss of human life first and materials later.
Now, in that case where that Air Force pilot died, it can't have been a case of one mistake that trickles through the supply chain and it ends up someone dying. It must be a series of mistakes that happen. So in this case, someone was intentionally selling counterfeits, and then someone purchased a part, didn't realize it was counterfeit, but didn't do the due diligence. It gets put into an aircraft, no one checks the part, and then you get to the very end where it's not maintained over a period of 3 years and someone dies. Do you see that as being essentially a form of shared blame across the entire supply chain, or do you think it's more of a case of there is one person to blame, and that's basically the part where you can put all the blame on?
When I was much younger, I used to want to believe that life was simple enough to believe that there was this criminal overmind that was maniacally orchestrating the death of many, many people. But in truth, I believe now that most of the tragedies that we see in life are a series of, I won't say innocent, but innocuous mistakes being made that compound over time. And so I would suspect that in the end, what we would find is that Lieutenant Schmidt's death was the result of a series of multiple cases of what might be considered minor negligences.
Yeah.
Which at the most would end up being just willful ignorance of people who just didn't want to look hard enough or dig deep enough or just take the time to do the job completely. We live in a world today that is moving incredibly fast, and everybody wants everything now. And when you're moving at a high rate of speed, there's only two things that you can compromise on to achieve that velocity of activity, and that's money or quality. And in the end, when you're having to make that decision and money is not under your control, the only thing you have left to sacrifice on the altar of speed is quality. And
so that's rather interesting, because you would expect a military application to have more funding than it could possibly need, and so you would suspect that at least with military funding you would have the time to check the quality.
There's an abundance of money available to the military, but there's also an abundance of oversight. And every single department and every single function within any military branch, and it's easy to point our fingers at the U.S. military, but I suspect this is true of every branch of the military in every country in the industrialized world. There's a budget for all of them, and they are all trying to accomplish the same thing. Their downstream customer needs what they need now and needs it cheap. And that's what we are all trying to achieve, both in the military and in the commercial supply chain.
Now, would it also be fair to say that there might be communication disconnects between supply chains? So, for example, let's say you start at the very beginning with a capacitor. You know it's military rated capacitor, and you know it's a counterfeit. But if you think it's only going to be used in some minor application, you might be happy to risk putting that part in there. But if the people supplying the part at the very beginning knew that it was going to end up in an Air Force aircraft, you might think twice about not being as due diligent. So do you think there might be a disconnect between the application and the source of the parts?
I think sometimes, but I also think timing can affect it as well. If you take that same scenario and say at the beginning of the month, the seller, the supplier, may say to themselves, you know what, we know this is going into a high reliability, sensitive application, so we shouldn't do this, so we're not going to sell this one. But it's the end of the month and they're trying to make their numbers. Now it's a far greater temptation to sell that part into that application with the justification of, we're pretty sure it's going to work. So let's go ahead and take that risk because we got to make our end of month revenue.
So unfortunately, human nature is basically prevalent, even right up until applications where safety is absolutely critical. So you have the American Air Force who are purchasing parts, and you've got some supplier, which means that some high-end supplier who's been vetted is still able to provide counterfeit parts.
At the end of the day, Robin, we can't get away from the fact that there are human beings involved. So absolutely. And it's never just one supplier. I don't think there's a single supplier to the United States Air Force,
of course,
that isn't the part of a chain. So there's segments all along the way. But I wish it could be that simple, but it is always a far more complex answer than any of us would like.
And considering the fact that aircraft are manufactured by maybe a handful of companies around the world, I can only think of 2 or 3 who actually make these types of craft. It makes you wonder how even their engineers were able to put this board together, not look at a part and go, that part looks a bit dodgy. And to speak from personal experience, I purchase thousands and thousands of components a month myself because I do my own thing in my own time. I have my own business. But I have to be very, very careful when buying logic chips, especially because I can always tell that if you buy any TI chip from China, the chances are it's going to be fake, and you can see the signs from a mile away. It's got the wrong font, it's got the wrong style, the wrong shape, it's got weird looking pins, and so it makes you wonder how a professional engineering company can produce an aircraft, look at a board, and not sort of question what it is that they're looking at, especially if they've got strict quality procedures.
Well, in your typical supply chain, the engineer who designed the board never sees the board that gets manufactured. They see the prototype that they built, and then they send the specs off to an independent third-party contract manufacturer who then sources the parts, builds the boards, and sends them off through their own quality control department.
Right. And so the issue is that you've got this kind of like fragmentation across the supply chain. So the engineer's designed it, built it, and he knows it's going to be good because the parts he's chose, but he can't control the person buying the parts and can't control the person putting the board together.
And that's where you start getting into the discussions about the types of failures that you'll see. There's the difference between a catastrophic failure of a component and a latent failure. Latent failures are those that the part may pass initial testing, but fail once under the full stress of the component. And so you may have parts that are going to fail later under the stress of actual use, but it'll pass functional testing once it's mounted on the board and it's going through the design testing as laid out by the engineering team after assembly. Then that gets uploaded into the full assembly, that gets loaded into the black box, that gets loaded onto the aircraft. And now when it's on the ejection seat and it's being shot out of the aircraft with 7 Gs and at 600 feet, the parachute doesn't deploy. That's when suddenly you find out that part that you just sold after stripping it off of a board 4,000 miles away that you thought was going to be okay, you just exceeded its lifespan.
And that, to be fair, it's very, very scary when you think about it, because it's not just the Air Force who are going to be vulnerable to this kind of thing. I can also imagine aviation, the aviation industry in general.
Absolutely, but it goes even beyond that. If you think about the last time you were in a hospital, how many electronic devices did you see in the hospital monitoring our vital signs? But not just that. Now we rely on them to administer medications. No longer do you have nurses just drawing the med out of a vial with a syringe. Now they hook up a bag and let the device administer it for you. So if you've got a faulty electronic component and that thing goes haywire, you could overdose a patient inadvertently and not even be in the room. Our automobiles these days, as we move further and further away from drivers driving vehicles and autonomous vehicles, a simple logic device failing could suddenly send a vehicle careening into a crowd of people at 120 miles an hour. And I don't mean to be a fearmonger on this situation. It's just a real reality that we have to deal with.
I don't think it's fear-mongering at all. I think it's an extremely serious point. And this is one of the reasons why I've always been a little bit against autonomous driving, because you've got a high-speed metal box traveling at goodness knows what. It's traveling at high speed. It's made of metal, and whatever it hits, it's going to kill. And you've got a software system that's basically monitoring the road, and you're hoping to God that this thing is able to pick up all the dangers and then drive as required. And like you say, all it takes is for the LiDAR sensor to break, a capacitor to go wrong, the radar system to fail, or the main microcontroller to fail, and suddenly it could just decide to make a hard right turn and go through a crowd of people.
That is a fact. However, as you expand your vision, our lives are so dependent on electronics. It's beyond just the obvious as well. You think about the living conditions that we have. So much of it now is autonomous. Our utilities, our environmental controls. Very few people are involved in monitoring those systems anymore. We are completely dependent and trusting in the systems themselves that are completely reliant on the electronics around us. Here in the Southeast United States, every summer we get to enjoy beautiful thunderstorms every night, and they remind us just how dependent we are on our electricity and our electronics when the power goes out for a day or two. And it's a great reminder that it is just a simple act of nature that takes away all of these comforts that we're used to. And I think about the fact that so much of this is dependent on such a small thing as a capacitor or a resistor that can be faulty out of manufacturing just in a normal, good environment, let alone in a counterfeit situation.
And so I think it'd be fair to say that as technology progresses, we become more dependent on it. As circuits become more complex, there's more points of failure. And so we get to a situation where the counterfeit issue becomes more imperative, not just because we've got the nature of the application being more dangerous or more sort of involved with people's lives, but the fact that there are just so many parts that can go wrong. And so we have to minimize the chances of that failing.
Absolutely, and mitigate it as best we can and be prepared for that. Redundant fail-safes are going to become critical as we have more and more of these systems regulating these important parts of our lives.
Fantastic. Now, this is where the really important question comes in. Considering everything that we've just talked about in terms of counterfeit devices, how does Flip Electronics come into the picture?
Oh, love this question. So historically, when it came down to design cycles, your only true answer for avoiding counterfeits was to buy parts directly from the manufacturer. Your next best bet was to buy them directly from an authorized distributor, aka a franchise distributor. That worked out really well so long as the product that you were supporting was using active products. As soon as the products became obsolete or end of life, you were forced into the gray market, or God help you, the black market, where you were buying from who knows who, Joe's Crab Shack selling resistors.
Yeah.
Flip Electronics 7 years ago was formulated out of the idea, the knowledge, basically, that manufacturers have stock sitting on their shelves, sitting in their warehouses, that we knew the manufacturers did not want their normal mainline distributors marketing, but that was available. And we knew there was a demand for it because we knew that there was companies whose life cycle of their products exceeded the life cycle of the parts that were on it. So we began working on relationships that had been built over, again, to age myself, decades of relationships and working relationships. Folks that we used to drink beer with in college who are now in the C-suites of some of these leading companies. We began to open up those conversations and began to expose this business concept of, hey, we want to open up this new market of marketing these parts, providing traceability and provenance, if you will, for these parts to this demand segment, thereby bypassing the gray market, but not providing any sort of threat to your normal business model. And it took about 2.5 to 3 years before we were able to finally prove the business model off. And once we did, I believe the industry woke up and saw the great value in it. And so now what has happened is Flip has become a way for companies to begin to source and supply their obsolete needs with legitimate, solid parts that have been handled properly, so that they know they're getting good quality product with traceability to support those legacy product lines without having to go into the gray market and take the chance on counterfeit product.
Now, I'd like to pick up on a point that you just said there, and I think it's very important to emphasize this, which you said handled properly. Now, the original manufacturer of those parts will always make sure they're in the correct humidity, temperature, storage conditions, all that kind of stuff. When that gets transported to maybe a distributor, that's where you start to go, did they really store it correctly? Did it have the right humidity? But what you're saying is that essentially Flip Electronics is not like a regular distributor. You are essentially an extension of the manufacturer, because you will take those wafers and store them as per the manufacturer's requirements. And so when people go to you to purchase those parts, it's essentially as good as going to the original manufacturer.
So I'll take it a step further than that. We do have a saying here at Flip that rule number one is the manufacturers make the rules and they break them anytime they want. Flip adheres to industry best practices for handling, whether it's J Standard 033 for humidity or ANSI ESDS 2020 for static control. We have actually run into manufacturers that do not adhere to those standards themselves. When we have those cases, we still manage to maintain those standards. So in some cases, we exceed the manufacturer's handling standards to ensure that we manage to maintain those industry standards. Because at the end of the day, we know that our customers are expecting parts that are going to perform. And that's ultimately what our goal is to meet our customers' expectations even if that exceeds the manufacturer's expectations.
It sounds like you need to put the slogan on your website, better than the original.
I would hesitate to do that. I'm sure that would burn bridges.
Now, I actually did a podcast with Flip Electronics not too long ago, and they were saying that they, and correct me if I'm wrong, but you also do wafers as well as the actual chip package as well, don't you?
I saw that podcast with Duker Dapper. It was fantastic, by the way. Yes, when we purchased Resurgent Manufacturing Services, we picked up the ability to handle die and wafer storage. Prior to that merge, we did not have the capability. Everything we did was in finished goods, and that is still a core feature of our business. But with picking up RMS or Resurgent, we have expanded our handling, and that continues to grow and becoming a growing segment of our business. And it's one we're very excited about because it's also allowed us to open up the possibility of working with our manufacturer supplier partners to not just look at inventory that they've got available on their shelves of finished goods, but also to look at die that they have on their shelves and resurrect product lines and product families that may have been shut down 10, 15, 20 years ago, that there's no finished goods whatsoever on the market. Now we're able to make that available.
And I think that ties in quite nicely to the Air Force example because, as a lot of engineers know, the Air Force and a lot of military equipment, as advanced as it may look, a lot of it's actually quite dated because you need to have parts that have been proven over years and years and years. So you can't just use the latest stuff all the time. So you tend to find a lot of military systems are based on 20, 30-year-old technology in some cases. So would it be fair to say that in the case with the ability to store dies and resurrect products from 30 years ago, the Air Force in that case could have benefited massively from Flip Electronics?
Certainly, from an opportunity like that would have definitely been a resource for them. In decades past, there were foundries here stateside that did just that. I believe it was in the 80s that we really began as an industry to offshore increasing amounts of productivity. That went away, and I believe that we're seeing that reshoring now going. That interest going up more and more, and I believe that we'll see that trend continue for that very reason. That was a mistake that was made, and I think we're going to see that reversal.
Just to be clear, is that the mistake that the America started to shift its smaller device range abroad?
I'll clarify by saying it wasn't an American mistake. I think it was a worldwide industry mistake.
Yeah,
we began to offshore all of our productivity instead of having a longer view on what was going to happen to our product lines.
And to be very clear, because I think it'd be fair to say that, especially in America and the West, the foundries that we do have tend to be quite cutting edge. So you're not particularly producing op amps and stuff like that. You tend to shift those to the Far East. And so, are you saying it's those kind of devices that we need to bring back as well?
Yeah, I think that the more cutting edge technologies, in my opinion, we should be reshoring. I think that the current struggles with China especially indicates the vulnerable state that we put ourselves in when we were offshoring our latest technology into what could only be classified as politically unstable regions. We really put ourselves in a dangerous position there.
And you know what? It's a really interesting phrase, politically unstable or dangerous. And it's funny how, especially in China, around the 90s and the 2000s, it was starting to adopt a more capitalist approach. And it was, I will go on record to say that I think it was improving itself in a very good way. It was becoming more Western. And then suddenly around 2010, it kind of just went backwards. With the rise of, I think it's Xi Jinping and stuff, when he was becoming more authoritarianism. And so you get this really weird situation where China has moved away from trying to profit from the West by being its manufacturer and is now trying to almost become more independent. Would you say that is the case?
I would wholeheartedly agree with that, but I believe in the old saying that hindsight is always 20/20, and it's very easy for us to look back and say, "Oh, we should have seen this coming." I believe the world as a whole wanted to be optimistic in the 90s and the 2000s on the direction that China was going in.
Because it did look good. It was positive for a while, and it was adopting all the new practices and stuff. And then suddenly, something happened, and it switched.
We had the same sentiment towards Russia as well.
Oh my goodness, yeah.
Recently, they showed a different side of the country than we wanted to believe was still there.
And I think that's a real shame because like you say, the early 2000s, all these countries were developing, their GDP was going up, their living conditions were becoming better, they were becoming more integrated with the West, there was better relationships. And for reasons that are kind of hard to understand, well, I suppose they're not really that hard. You've got a leader in power who wants to stay in power, which often happens in these regimes, and then suddenly they becomes closed-minded, they make strange decisions, they irritate everybody, and so now we've got this ongoing issue with these two major superpowers. So, and it's interesting to see how does that relate to the counterfeit issue, do you think?
Well, I think anytime we start to see political unrest, that of course reverberates across economic markets. And as the economic markets become increasingly unstable, that causes banks and lending institutions to become unsettled, which causes money to become less available. And therefore, you start to see inflation go up. And we're seeing that now. As all of these financial pressures begin to increase, costs go up. So the need for savings increases. Once that financial pressure starts to go up, now again, we start to see, I have to have this cheap.
Ah, right.
When you need something fast, you only have two things to sacrifice on the altar of speed, and that's money and quality. And if money is not an option, the only thing left is quality. So then the natural consequence is going to be you're going to see an increased demand for potential counterfeit components showing up in the supply chain. And so as we watch this instability increase across the supply chains more than ever, it's important that we remain vigilant in looking out for how we're handling our parts, how our downstream suppliers are handling their parts, and what we're doing to mitigate the threats of these counterfeits from entering our supply chains.
So it's interesting you mentioned about the struggles with money and inflation and savings and how that has an impact on counterfeits. A little bit off topic, but not quite. And I'm curious to get your impression on this. I'm sure you're aware of back during the COVID pandemic, there was a report that went quite viral. It was never mentioned which company it was, but I do believe it was an automotive one. And apparently there was an automotive company that purchased old washing machines, or I should say new washing machines, scrapped them for the parts that they had, and then used them in their vehicles. My question to you would be, do you think that could have incurred some side effects if they were pulling parts out of products that had already been manufactured and then using them in an automotive environment? Do you think that could have incurred some issues?
I'm going to give you the politically correct answer.
Give me the political. It depends.
It depends.
I have no strong feelings on the subject.
Potentially it could, but there are ways to mitigate that. And this is the thing is, you used a phrase earlier, and this is very poignant and important. When it comes to, there's a reality to obsolescent parts. And the reality is that there is a finite number of anything.
Yeah.
And eventually there just aren't any more parts available. And when there aren't, and you still have to get that part, you may have to go out in the open market and get it.
Yeah.
In which case there are still things that you can do to mitigate that risk. And there are tremendous standards that are written. There's a tremendous amount of information that's out there and available on testing that you can do in order to validate the parts. I would like to believe that the alleged car manufacturer that allegedly bought washing machines to strip them of parts that they needed for their cars did functional testing on those components before they installed them to ensure that they were going to meet the specifications that they needed for those parts. In which case, I don't think there's a threat. I've been involved in aerospace component distribution for many years. I have looked at the automotive standards, and they make the aerospace standards look like a walk in the park. So with that knowledge, oh yes, automotive standards are significantly more stringent than aerospace. I used to wonder why, and then somebody pointed out to me that statistically there are more people in cars at any given moment than there are in aeroplanes.
That actually makes sense. You've got billions of cars around the planet, so that actually does make sense when you think about it.
Yeah, and if a plane goes down, if a 747 goes down for a faulty component, you will probably lose on average 500 to 600 lives. If a faulty component in a Ford F-150 starts causing fires, you could lose far more than that. So I would have to believe, based on what I know about the automotive industry standards, that they put those parts through a rigorous amount of testing to mitigate the risk of them failing.
Yeah.
And frankly, again, it goes back to that rule number one, that the manufacturer makes the rules and breaks them anytime they want. I'm sure that automotive manufacturer has a policy in place that states that they will only purchase components directly from the component manufacturer that were authorized distributors. But in their desperate times, they broke their own rule to get those parts so they could get their trucks off the line.
And in that situation, in that scenario, do you think that's something that well, let's start again. If they were looking for a semiconductor part specifically that was only found in a washing machine for God knows why, do you think that's something that Flip could have helped with?
So in that case, if their purchasing department had reached out to us and it was a line that we were active for, that we were authorized for, then if we didn't currently have it in stock, we would reach out to one of the manufacturer of the component and see if we could either find that part or resurrect it. Now, again, to be honest, because of our focus being in obsolete and end-of-life components, it probably wouldn't be within our wheelhouse normally.
Yeah.
But that doesn't mean that we couldn't support them with that, because even within the active lines, Flip is still able to support people and help them out through our relationships. So we're not exclusively end-of-life and obsolete. We can certainly help people still with their active component needs.
Now, Flip Electronics is not the only company out there that offers obsolete chip sourcing and supply chain management. My question to you now would be, what is it that separates Flip Electronics from the competition?
That's a great question. I think it's twofold. The first is the value proposition that we offer manufacturers. We have a different business model than our competitors in this segment, in that our approach to our manufacturer partners is to work with them in helping them disposition their existing inventory of obsolete material and actively market it, rather than just passively take it off their hands and hope something happens with it.
Yeah.
But we are also working with them in such a way as to make sure that we are reporting back to them with accuracy and with speed on what sort of activity that we're seeing, so that they've got a good insight into the marketplace.
Right.
And that provides them with the intelligence that they need on what's happening with their products across the spectrum as well. The second is how we serve our customers on the other end of that as well. And that is that we are looking to help customers identify what's going to continue to happen with these parts, what the actual supply looks like for these parts, and give them a more realistic appraisal of what the lifespan of this part's going to be, so they can better identify the true lifespan of the product that the part is going into and determine whether they need to redesign or whether they need to abandon the project altogether.
Fantastic. Now, just before we wrap up this podcast, I've got one more question for you. For the engineers who are currently watching this video, if they will want to get involved with Flip Electronics and look at their part offerings and want to get into more discussions about the issues that they face, what would you recommend that they do?
The easiest way to reach out to us is through our website, www.flipelectronics.com. You can also send an email to info@flipelectronics.com. Or, of course, I would be remiss not to mention join our Facebook page, as well as find us on LinkedIn. And we would be more than happy to hear from you and get back to you with any questions that you've got.
Fantastic. Well, I would just like to say it was an absolute pleasure having you on the podcast today, and it was a really engaging conversation. And honestly, it's the first time I've ever heard of someone actually dying from counterfeit parts. So that was one hell of an eye-opener, to say the least. So all I can say is thank you ever so much for taking the opportunity to be here today.
Robin, it's been a great pleasure. I appreciate the opportunity, and I wish you all the best. Thank you again.
Same here. See you next time.